A thermocol ice box is a cheap and effective method for storing small quantities of cooked food in summer in particular. A cubical ice box of side 30 cm has a thickness of 5 cm. A 4 kg of ice is put inside the box. Estimate the amount of ice remaining after 6 hours. The outside temperature is 45 degrees Celsius and coefficient of thermal conductivity of thermocol 0.01 joule second raised to minus 1 Kelvin raised to minus 1. Latent heat of fusion of water 335 into 10 raised to 3 joule kilogram raised to minus 1. Amount of heat energy conducted per second, that is Q is equal to Ka dt by dx, where K is thermal conductivity of the solid, A area of the surface, dt difference of temperature between two sides of the surface, and dx the length of the surface. In the problem we have thermal conductivity of thermocol K is equal to 0.01 joule second raised to minus 1 Kelvin raised to minus 1. Area of one side, for that we have the length of one side is 30 centimeter. First we have to convert it into meter. So 30 into 10 raised to minus 2. Area is equal to length square, that is 30 into 10 raised to minus 2 into 30 into 10 raised to minus 2. We get 0.09 meter square. Now the length or thickness of the box. Dx is equal to 5 into 10 raised to minus 2. Change of temperature dt. Outside temperature is 45 and inside the box is 0. So 45 minus 0, it is 45 degrees Celsius. The value in Kelvin scale will also be the same, that is 45 Kelvin. On substituting the values in the equation, Q is equal to Ka dt by dx. K is 0.01. A is 0.09. dt 45. Dx 5 into 10 raised to minus 2. On solving we get 0.81 joule per second. The time is T is equal to 6 hours. To convert it into second, multiply with 60 into 60. Now 6 into 60 into 60 is the time taken. Heat radiated in 6 hours equal to the answer 0.81 into 6 into 60 into 60. Heat is radiated through all the 6 sides. So multiply the answer with another 6. Now we get heat radiated through all the 6 sides as 1,04,976 joule. A brass boiler has a base area of 0.5 meter square and thickness 1 centimeter. It boils water at the rate of 6 kg per minute when placed on a gas stove. Estimate the temperature of the part of the flame that is in contact with the boiler. Thermal conductivity of brass 109 joules second raised to minus 1 meter raised to minus 1 Kelvin raised to minus 1. Heat of vaporization of water 2256 into 10 raised to 3 joule kilogram raised to minus 1. The amount of heat radiated per second through a solid Q is equal to Ka dt by dx, where K is thermal conductivity, A area of the solid, dt temperature difference, and dx the length or here thickness of the boiler. Amount of water that boils is 6 kg per minute. To convert or to find the amount of water that boils in 1 second, that is the mass of water that boils in 1 second, m is equal to 6 kilograms divided by 60. So m is equal to 0.1 kilogram per second now. Thickness dx is equal to 1 centimeter. On converting to meter, 1 into 10 raised to minus 2 meter. Area of the boiler 0.15 meter square. Heat used to vaporize, that is the heat transmitted through the solid, equal to Ka dt by dx. This heat is used to vaporize the water. The amount of water that vaporizes is taken as m. Now, the heat used by m kilogram of water to vaporize is given by m into Lv. So we can equate the two equations, that is m into Lv equal to Ka dt by dx. The amount of heat absorbed by water is used for vaporization of water. So mLv is equal to Ka dt by dx. Now we can substitute the values. M is equal to 0.1. A is 0.15 meter square. Next, Lv is equal to 2256 into 10 raised to 3. K 109 dt. We have to find that this is the temperature difference. Dx is the thickness of the stove or the boiler. It is 1 into 10 raised to minus 2. Now we have to find the value of dt from this equation. Dt is equal to, we can take this 1 into 10 raised to minus 2 to the right hand side, and 109 into 0.15 towards the denominator of the right hand side. So dt is equal to 0.1 into 2256 into 10 raised to 3 into 10 raised to minus 2 by 109 into 0.15. We get 138 Kelvin. The temperature difference remains the same when we convert to Celsius scale. So it is 138 degrees Celsius. So the temperature difference T1 minus T2 is equal to 138 degrees Celsius. T2 is the temperature of boiling water. It is 100 degrees Celsius. And T1 is the temperature of the flame, which we have to find. T1 is equal to, we can take this T2 on the towards the right hand side. T1 is equal to 138 plus T2. T2 is 100. So we get the temperature of the flame T1 as 238 degree Celsius.